My name is Nicole Kirsting and I'm an assistant professor at the University of Arizona. The paper I wrote with my colleagues Mei-Kuang and James Stigler is called Value-Added Teacher Estimates as Part of Teacher Evaluations, exploring the effects of data and model specifications on the stability of teacher value-added scores. For quite a while now, there has been a lot of talk about value-added models as a promising way to create more objective teacher evaluations. And various claims have been made about the appropriateness and limitation of different approaches. We were left with sort of a black box feeling and wanted to better understand these models. And some evidence seemed to show that teacher rank ordering or performance group designation of teachers depended considerably on how their scores were estimated. We focused on three issues. First, the effects of various student and classroom characteristics on value-added estimates. Second, we focused on the stability of value-added scores within teachers over time. And third, we focused on the effects associated with the number of students whose scores were available to estimate each teacher's value added. For our research study, we used data from one of the largest school districts in the nation. To properly be able to attribute any changes in teacher rank ordering or performance group designation to changes in model specification, we created a single data file for our analysis that contained no missing data. Here are what we think are some of the key findings. First, we observed a fair amount of stability in our value-added scores. About 2/3 of the teachers remained in their respective performance group, regardless of how we estimated the value-added scores. To figure out why we might have gotten the results we did, we went back and examined student test score correlations within students over time, as well as correlations between different student cohorts by teacher. Either set of correlations was high, around 0.8, indicating not only that any of the student scores was a pretty reliable measure of student prior learning, or that individual student learning was quite stable over time, but also that teachers had very similar students across the 4 years under study. Part of the stability and value added we observed might be explained by the high correlations in the student scores. These are the kind of insights that can make a big difference to policymakers, because they can request that data requirements are empirically determined for a given district or state. Second, the number of students that are included in estimating a teacher's performance had the strongest effect on teacher reclassification into performance groups. Teachers whose performance is estimated from a few student scores might have been in a different performance group if they had had more student scores available. One way to make sure that we are cognizant of these potential quality differences in value-added scores is to set minimum sample size requirements, which could either be absolute numbers, as some have proposed, or based on an acceptable level of reclassification percentages. Third, and last, when we compared value-added scores of teachers, there was a significant improvement in those scores over the first 4 years. Our analysis also show that value-added scores become a lot more stable after about 5 years. Implications for policymakers are that the use of value-added scores for beginning teachers needs to be done with very great caution.